constructing models from data points. This is where the fun really happens. So let's just jump right into problems and see what happens. In 1980, the average cost of a pack of cigarettes was $1. I also wasn't alive. It was a long time ago. In 2000, the average cost was $3 per pack. We will use this information to create a linear model for prices. So first we're going to calculate the slope. When you calculate the slope, remember that slope is the change in the y values over the change in the x values, or the vertical change over the horizontal change. So the first thing I need to do is say, okay, I'm dealing with some pieces of information here. So 1980, it was $1, and in 2000, the price was $3. So really the only thing we care about is like 1980 is really where we start caring. So I'm going to say, in 1980, x equals 0. I'm going to use this as my starting point. So that would mean that my ordered pair is going to be 0, 1. Because if 1980 x is 0, there's my x value. We know that the cigarettes were $1. I love this for us. Now, thinking through, 1980 to 2000 is 20 years. So that means that in 2000, x would be 20 because it's 20 years later. Okay, so my ordered pair would be 20, and then the price was $3. Now I can find my slope. Remember that our slope formula, y2 minus y1 over x2 minus x1. Substitute in what we know. Well, x1, y1, x2, y2. So I would take 3 minus 1 over 20 minus 0. And I get 2 over 20, which reduces to 1 over 10. And there's my slope. Ta-da! Great. Well, what does that mean? So let's use the slope value in a meaningful sentence. Y'all, think about this. Slope is the change in the y's over the change in x's. The y values, right? The y values are money, the cost of a pack of cigarettes, right? So we're talking the money of cigarettes. And the x values are the years since 1980, because I started in 1980. My slope is 1 over 10. It's positive. That means we have increase. So I use the 1, think this through, for every, I can't spell, I'm so sorry. Okay, so the bottom is 10 years. For every 10 years since 1980, cigarette prices have increased $1. You also could say the price of cigarettes have increased $1 for every 10 years since 1980. It doesn't matter which one of those you start with, but those are your two statements. Cigarette prices have increased by $1 for every 10 years since 1980. That is what my slope represents. I am a visual person. I like to write it out with the cigarettes over the years and then put my fraction, and then I can use that to write my sentence. So let's construct a linear model that predicts the cost of a pack of cigarettes after 1980. So I know my slope is 1/10. My starting amount is 1, because remember, in 1980, the price was $1. That's how I get my y-intercept. So my linear model would be y equals my slope times x plus the y-intercept. Now we can use that information to estimate the cost of a pack of cigarettes in the year 2020. Okay, remember that in 1980, x was 0. In 2000, x was 20. So in 2020, another 20 years later, x is going to be 40. Substitute that in. So y equals 1/10 times 40 plus 1. Well, what's 1/10 times 40? Well, if you want, in your calculator, you could type in 1 divided by 10 times 40, and it'll yield an answer. Or you can multiply fractions. 10 goes into 40 4 times. So that would give me 4 plus 1, which is 5. So we would estimate that in the year 2020, the average cost of a pack of cigarettes would be $5. That's what that tells us. In 2020, we expect cigarettes to be $5 per pack. And I don't smoke, so I don't even know if that's right or wrong or close, but that's what this information tells us. Let's do another one. One more question here with multiple parts. The population of Flat Rock, Illinois was 4,800 in the year 1900, but it dropped to just 450 by 2020. Calculate the slope, rounded to the nearest hundredths place. So now we're going to take that to a decimal. But first, we have to figure out our ordered pairs. Anytime you're given time, okay, time is going to be your x value because time is independent. We don't impact time. Time impacts us. Ooh, that was real deep. Whatever. Okay, so 4,800 in 1900. That's my earliest year. So I'm going to say that 1900 means x equals 0. So if I have 2020, how many years later is that? Well, 2020 minus 1900 is 120. So I have my x values. That will lead me to my ordered pairs. So in 1900, my population was 4,800, and in 2020, my population was 450. Let's find our slope. So I'm going to use this as x1, y1, and then this would be x2, y2. So 450 minus 4,800 divided by 120 minus 0. So 450 minus 4,800 is negative 4,350 over 120, which is negative 36.25 over 1. I put it over 1 to help us with the what does this value represent. So I know my slope, negative 36.25. Go back to that last example. So remember, right, we talk about y's over x's. What do the y's represent here? Well, population. What about the x's? Well, the x's are the years since 1900. So what does this mean? What does our negative 36.25 over 1 mean? Well, the population decreased, because it's negative, decreased 36.25 people every year since 1900. Right? Every 1 year since 1900. So that means every year 36 people left and never came back. They might have moved, they might have died, nobody knows. But every year 36 and a quarter person left. Like that was the average. Okay? So let's construct a linear model. So we know in 1900, that was when x was 0 and the population was 4,800. Our ordered pair was 0, 4,800. That tells us that B is 4,800, and we know that we found our slope to be negative 36.25. So our our linear model, y equals negative 36.25x plus 4,800. Great. Let's use this to predict for the year 2025. Okay, so again, x equals 0 in the year 1900. So in 2025, that's 125 years later, so x would be 125. So our equation, negative 36.25x plus 4,800, we substitute in our 125 for x, and we solve. Order of operation tells us to multiply first, so we get negative 4,531.25 plus 4,800, and when I add those, I end up with 268.75. But y'all, remember that y's represent people, so we're going to have to round this to 269 because you can't have a partial person. You just can't. So 269 people. That's how many we would expect if this trend continues in the year 2025. We can use linear models to predict. That's what we do. Can this trend continue indefinitely? Hopefully, you easily and confidently say no, because eventually you'd have 0 people. And once you have 0 people, you can't lose anymore. All right, so once everybody has moved out of this town, the linear model has to stop. You can't say, well, now we have negative 7 people here. That's not how it works. So no, this definitely won't work forever because eventually you'll have 0 people and then it's over.